So my next guest today is Jim Vicarro. He is from a company called Tek Systems. Welcome, Jim. Thank you for coming in.
And good pronunciation on the Vicarro, too.
Yeah, thank you. Well, I practiced, you know. So anyway, you're in the business of nitrogen generators.
Correct.
It's a growing business because, as we discussed earlier, the increasing miniaturisation in the electronics industry is driving the higher need for the use of nitrogen in reflow. Tell us some of the benefits, though, of using a nitrogen generator.
How much time do you have? No, I try to narrow it down. There's three major things that we focus on, which is what I call the 3 C's. It's the cost benefits. We are the most cost-effective way of using nitrogen with on-site nitrogen generation. It also is consistency. With our generators, consistent purity, consistent flow. It's happening in real time. You don't have any standby losses or anything like that. And the biggest thing is the control. You're in control. Not having to worry about delivery, not having to worry about any of those things. You literally are in control of your own destiny.
Yeah, and you only make it when you need it.
You only make it when you need it, correct.
Right.
You've been paying attention.
So therefore, going back to the consistency, I mean, that's quite important, because then you can get, for consistent results. It helps to play into the sustainability argument that everybody's talking about today. And it gets the quality, keeps your quality at the level that you need. So the alternative is, of course, bottled gas. But I mean, there's a lot of drawbacks with that too.
Sure.
Can you talk about the comparison?
Yeah. So bottled gas, whether it be in what's called dewars or in large tanks, you're taking liquid nitrogen and converting it into gas. So just by the very nature of that, the processes there, while they are controlled, there is some inconsistencies there. You also have what's called standby losses. So whether you realize it or not, that liquid, it's offing, so it's losing some of that volume. So you're actually using it, whether you realize it or not, it's going away. So that really plays into the conversation regarding the ROI calculation, because we show that only creating it when it's needed, you eradicate that side of the equation. So
right. Okay. So explain to me a little bit how the nitrogen generators actually work. What is the process that's inside? So
the actual how does nitrogen create it, or what does it do for you?
Yeah. How does it do it? Yeah.
So it's actually it's simple. It takes molecular construction. I'm a structural engineer, so the whole molecule thing escapes me sometimes, but it's pure physics.
Okay.
So you're forcing compressed air through what we have. It's called CMS. It's carbon molecular sieve, and that carbon attracts the oxygen molecules.
Okay.
Essentially absorbing them.
Yeah. So
leaving only the nitrogen, and then that goes into a storage tank.
Yeah.
And the process swings from tank to tank, or twin towers, as we call them.
Okay.
The process repeats itself every 30 to 45 seconds.
Okay.
Pretty simple. In its simplest terms, I talk about nitrogen, and hopefully marketing won't be mad at me. Nitrogen good, oxygen bad. So wherever the presence of oxygen is seen as a negative, i.e. in the soldering process, the presence of oxygen creates dross, all those things that inhibit a good connection.
Yeah.
The presence of nitrogen helps.
Yeah. So I mean, that's obviously a filtering system that's inside your system.
Yes.
Do you need to replenish these filters? Do you need to change them?
Very simple. That's the other thing that I've been hearing a lot as I've walked around today, trying to minimize any kind of maintenance. It is as simple as you can possibly think. It's changing out filters, 3 filters every 2,000 hours of operation, so roughly 1 shift for the course of the year. So you're changing out once a year. Very simple. Doesn't require any kind of tech to come on site. Your facility folks typically can handle it without a problem. So pretty simple.
Great. Okay.
Even you could.
Even I could do it.
Even you could do it.
Gosh, that's saying something. So, okay. Final question. This is the big one. what about the capital cost of it? I mean, obviously there's a capital cost attached to this.
Sure. And this actually comes back to my structural roots. You're talking about, yes, it is a piece of capital equipment, but it doesn't require the infrastructure that large tanks would. Typically, large tanks are quite large, quite heavy, require some infrastructure changes to your slab. It also requires a lot of piping.
Yeah.
There's a lot of costs involved with going in that direction, where our units are small enough and mobile enough that you can actually decentralize. You can actually put two smaller systems, have some redundancy to it. There's a lot of benefits to that. I personally get a little concerned when you have one system supporting the entire operation. If it goes down,
Then
you're down.
You're down, yeah.
If you decentralize and have redundant systems, you have that ability. You're not 100% down.
Okay.
So there's a lot of benefits there, and it's a calculation. I am what I would call a solution guy. That if I don't believe that this is the best solution for you, I'm not going to.
I'm going to sell it to you.
You.
Okay, obviously it depends on the volume that you're doing.
Yes.
But at the end of the day, what is the average ROI on these systems?
Average ROI is that 18 to 24 months.
Okay.
Almost 100% of the time, that is what occurs.
Yeah.
There are some extremes that might go beyond the 24 months, but there still is that ROI. If you do the math and you're going to be using nitrogen in your facility
Makes sense.
for foreseeable future,
Yeah.
it's the way to go.
Yeah.
It's just getting over that hump that it is a capital expense,
Yeah.
which we try to soften as well with different ways to do that. So.
Well, it's fascinating learning about this. So I want to thank you very much for coming in and telling us about it. And wish you every success.
I appreciate your time as well.